is for year 11 methods. We're going to look at the 2018 SAC. Okay, so this is a slightly updated version. I think there was an issue with one of the questions in the SAC. I'm not sure if that's been rectified in this version of SAC. If it's not, then we'll just go to the solutions in the actual SAC. All right, so there are three different functions shown here. Find f of 0. So f of 0 means I sub in 0 for x, so y would equal f of x will equal 9, or f of 0 equals 9. G of -4 means I sub in -4 into the equation, so I can use the calculator to help me. -4 squared. So in place of x, you put -4 plus 15. So that's 19. H of x equals 0 literally means this equals 0. Okay, and you're just trying to solve that. Solve for x. So I'm just going to use the root function, x minus x, root 4 minus x squared equals 0, and then go interactive and solve. X equals plus or minus 2. Find the quantum intersection between h of x, f of x, and g of x. Okay, so you can do it both ways. You can sketch the graph of both graphs. So why don't we do that? So minus 5x plus 9, and we've got x squared plus 3x plus 15. Graph. I'm going to put both graphs on the same axis. Okay. And I need to make sure my window is good. Okay, so you see that I can't see anything properly. So I'm just going to go zoom. Just go back to standard if that's not good. So let's see. All right, good. So we've actually got, if I zoom out, make sure you zoom out just to check whether you have all the intersections. So we've actually got two intersections. So analysis, gsolve, intersect. So we've got one section at -7.16, 44.81, and another intersection at -0.84, 13.19. Okay, so it's really important that you follow instructions. It says 2 decimal places, so we don't want it to be exact. Next question. Now you can obviously use the simultaneous tool just so that you have another method of solving it. You can use this. You can use the simultaneous tool to solve this. Just go. Oops, not here. Click enter. So what you can do is copy and paste these two functions in. Now, obviously, because we're solving for x and y, you got to make y equals to that and y equals to that before you even solve it. So, and then you solve for x and y. Make sure in decimal mode. Oops, like that. And you're able to get an answer. So you get the same answers. So two ways you can do that. Next question. We've got a quadratic function. We know that x-intercepts are 2, 0 and 4, 0. Okay, so you need to be able to read function notation. So I want to sub. I know that in factor form, if I have x-intercept of 2 means this, positive 2, and x-intercept of positive 4 means that. It's opposite what you expect. Now, you got to be careful because the model already has negatives there. Your B and C value will actually be positive. So your B would be 2, your C would be 4. Now, for part B, you've got the y-intercept here, 0, 22.5. You're just going to sub that in to find the value of A. So 22.5 equals to A, 0 minus 2, which is just minus 2, and 0 minus 4, which is minus 4. Interactive and solve. So 22.5 equals x. Make sure you put I know you can do this on computer, but make sure you use your actual calculator and go -2, -4, interactive and solve, and I want to be exact because it's exact as instructions. Interactive event solve. I get a equals 45 on 16. Okay, so now go to the next part. Okay, let's go back. Question 3. Victoria opens a cafe in suburb Melbourne. The Victoria can model the cafe's revenue R by running costs by the function Rn and Cn, where n represents the number of coffees sold. Okay, these functions are shown below. So key thing is revenue is not profit, meaning revenue might be, you own a cafe, you're selling coffees. What you get from the coffees, from selling coffees, the money you get from coffee might be $1,000 per week. And revenue is purely money you get in. However, it doesn't account for the fact that you've paid, you're paid the staff you hire and the normal running costs of the business. So it could be lights and electricity and all that. So revenue doesn't count for the costs. Okay, so profit would be revenue minus the costs. Okay, because that's after you paid all your bills, whatever money is left over is the profit. Okay, so sketch the graph of Rn on Cn on the same axis. Now you got to be careful. Rn and Cn are both linears. They're both linears, and can you see both their y values are 500 and 1,000? So when you're drawing the graph, you're going to make sure your scale is correct, because if you put this on a calculator, 500, so if I put it on a calculator, 500 plus 2.5x, and I go draw it, you can see nothing shows up. Okay, and the reason for that is we got to adjust our scale, because we shouldn't be panicking if we just don't see a graph. It just means we got to adjust our scale. So if I adjust my scale for y between the smallest y value and let's say 2,000, and my x value from to 200, let's see if that helps. Okay, great. It actually shows us almost the intersection. So we're going to adjust our x value to say 400 to see if that helps. Great. Okay, helps. So I want to draw the graph. I want to label the x, y axis in dollars. And my x axis would be n, number of coffees. Okay, so let's choose a appropriate scale. My x, let's see where the intersection point is. Analysis G solve intersect. We're intersecting at 250 coffees. So if I go up by 50s, that might help. 50, 100, 150, 200, 250, 300. And I know that, my cost axis will be quite big numbers. So we might want to go up by thousands. No, not thousands, hundreds. So 100, 300, 500, 700, 900, 1,100. Okay, we'll do it like that. So I know my intercepts are at 500 and 1,000. If you're not sure, then just go analysis G sort of Y intercept. Okay. So I've got intercepts at 1,000, so here, and intercept at 500, which is here. And an intersection point between two graphs would be, or the point they have in common would be when you sell 250 coffees. So 250 is here, and it's at 1,125. So 1,125 is somewhere here, it's somewhere over here. Oops, it's a quarter of the way up the square. So you got to make sure you're pretty accurate. That's not accurate enough. So that's around here. And since that point's are common, I can draw a line because I know 2 points give me line. Oh, make sure I use a ruler so it's aligned properly. Okay, done. So label that point 250, 1125, and label your so this is your revenue, this is your costs, C of N, R of N. All right, let's answer questions. When will Victoria's revenue costs? What will Victoria's cost of revenue be if it sold 200 copies in above? So Victoria's RN is given by that. So R of 200 and C of 200. So we just need to sub in 200 from both equations and find out what that equals to. So let's go to the function. So I delete that. So this is revenue times 200 gives me 1,000. So revenue will be $1,000, and the cost 1,000 plus 1,000 plus 0.5n times 200 gives me 1,100. So analyzing a bit here, even though the question was asked, if you only sold 200 cups of coffee in a month, it's not very good because you're losing $100 in money basically, because you're $1,000 coming in, but $1,100 going out, so you're not making any profit. You're making a loss. How many cups of coffee needs to be sold before it gets to make a profit? Well, we know the graph intersects at 250 for X, meaning, or your N value, meaning that you need to sell at least 250 for the revenue to exceed the cost of running the business. So more than 250 cups of coffee. Okay. The reason why it's more than and not at 250, if you just sold 250, it means that you're neither making or losing money. But after 250, you are starting to make money. Without solving the equation, explain what this means. Okay. So what this means is Rn, which is the revenue minus the costs, is the profit, remember? So it means that if I were to solve this equation, it means I'm solving for n, for which the profit is equal to $200. So the gives number of coffees needed to reach profit of $2,000. Okay. Question 4. Okay, question 4 is a bit tricky because we're dealing with inverse functions. So we're given a function and we know there's two twin sisters. They're running. They're starting at point A at the end of the park they're going to point B. And they're running at different paths. So Hope's path is shown below. And we know that this direction is east, up direction is north. Okay, so find the value of H0 and H30. H0 is pretty straightforward. I sub in 0 into the equation. I get 0. I should get 0 because these both have x's in them. So if you let them equal 0, that goes to 0. H30. So I need to use my calculator to find what it is. So I'm subbing in 34 in place of x. So 1 divided by 450 divided by 450 times 30 squared plus a third times 30 gives me 12. Okay, great. Okay, we want to label the coordinates on the graph. Okay, so read the instructions very carefully. So 0, 0, and h of 30. So 30 would be here, and that equals 12. Okay, h of 30 equals 12. I actually believe in the original question, it wouldn't ask you h of 300. So I'm going to put this on as well, and you should get a value of 300. Okay, so this will be 300 300. Okay, h of 30 equals 12. I'll put that on just in case. 30 equals 12, so this will be 30, 12. Okay. All right. Now, what do we need to do? We want to find Francis's path. So Francis runs separate path to hopes, but her path was inverse function to that hopes. So we want to find a fully defined function for Francis' path. You can choose the function to have the same domain. Okay, both functions have the same domain. So domain of the original part of hope's path would be from 0 to 30, or 0 to 300. Sorry, 0 to 300. We just need to find the rule. Okay, so let's do this. Remember, to get the inverse, you swap the x and y's. So you go x equals to 1 divided by 450 y squared plus a third y, and then all I'm going to do is go interactive and solve for y. Okay, we've got two functions. Which one's which? Now, because I'm expecting the inverse to look something like this, okay, it's going to arc like this way, rather than this way. It's going to be the positive version. So it's really important that you select the right version for the inverse. So the positive version is over here. So let's go write it down. So we got 15 2x plus 25 minus 75. Okay. Now, draw Francis' path on the graph above. Now, can you see that we've got 0, 0 and 300, 300? Since they intersect on points which the x and y coordinate are the same, it means the original will intersect at those points as well, or the inverse will intersect at those points as well. So what you can simply do is go and draw it like this. Okay? So it's meant to be a reflection. Now I'm not going to be, unless I supply an axis, I'm not going to be super fussed about the axis, the shape being perfectly correct. There will be questions where I will expect the shape to be perfectly correct, but not this one. Okay, as long as it looks reasonable and somewhat a reflection of the original, that's fine. Okay. Now we know the domain of Hope's path is 0 to 300, so that's original. The range is also 0 to 300. Okay, so there's no tricks here. So remember, the domain becomes the range of the inverse, and the range becomes the domain of the inverse. Okay, so in this case, they're all the same. So there's nothing tricky there. Using knowledge of the inverse function, explain why Hope and Francis both start at the end of the same position, at the end at the same position. So this is because. So think about it. It's because if you look at Hope's path, we know the endpoint's 300, 300. Since we're finding the inverse function, we know 300, 300 would lie on the line y equals x, and so does 0, 0. So if I ever get a coordinate that's the same x and y, then I know the inverse will intersect at that point. So you have to just articulate that. I might type this in. This is because the endpoint point for Hope's path is 300, 300, since Francis's path follows an inverse path to Hope's, it will also intersect 300, 300, since it is on the line y equals x, where inverses and the original will always intersect. Okay, so that's just some knowledge of the inverses and the relationship of the line y equals x. Okay, So if you have the same coordinates, then that must be what the case is. Now, question 5 is a bit different. I won't go over question 5. I'll go over it a bit later, or I can go over it in the solution. So I'm pretty sure I have it here. So I'll just briefly go over this. Now, Sarah's moving house. Okay, the removal is charged so $500 if the truck has to drive more than 0 kilometers up to 10 kilometers. $750 if the distance is more than 10 kilometers up to 20 kilometers. $900 if the distance is 20 kilometers, more than 20, but up to 45, and $1,010 if distance is more than 45 kilometers. So let the function C be the cost and then represent the distance. Now, obviously, this pricing structure is a hybrid function. So $500 if between 0, not include 0, up to 10, $750 if it's between 10 and 20, $900 if 20 to 45, and 1,100 if n is greater than 45. Okay, so it's really important that you get the inequalities right and yep, the numbers right. Okay, so this is a type function where we basically have flat lines. Okay, you got to make sure you get the open and close circle correctly. So if you draw the graph, it looks something like this. So between 0 to 10 kilometers, it's 500. Now this should be open circle. Okay, that should be close. So there's some mistakes there. Then 750 to 200, open closed. Then between 20 to 45, okay, open closed, and then from 45 onwards, open circle and going forever. State the domain. The domain will be essentially 0 to infinity. Now, there's a mistake here that should be not including 0, okay? Because it wouldn't make sense for the removals to charge even though it hasn't traveled anywhere, okay? The range is just discrete data values, so 500, 750, 900, and 1,100, okay? So we'll go back to the question. So this is a different question altogether. Now I'll do question 6. Okay, so a piece of wire is 100 centimeters in length, bent as a shape, all corners measured in centimeters. Find expression for the perimeter in terms of x and y. So perimeter would equal, now I know that this length would be 2x plus x plus 2x. Okay, because if I go horizontally, that's 2x, x, and 2x. So if I add it all together, the perimeter would equal, let's work it out. How many x's do we have at the top? 2, 3, 4, 5, 6, 7. 7x plus 2y's. And at the bottom, it's still, how many x's do we have? 4, 5x. So the perimeter would equal 12x plus 2y in total. Okay. Find y in terms of x. We know that the piece of wire is 100 total. So we know that perimeter equals 100. So 100 equals 12x plus 2y. I'm going to make y the subject. This says y in terms of x. So 2y equals 100 minus 12x. Rearrange. Y equals 250 minus 6x. Okay, so that's 50 minus 6x. Show that the area closed is that. Show that means show by step how the area is given by that. So the area would be, now the easiest way to do the area is if I go the total area minus this part, okay? So it will subtract this part. So total area of the square would be, okay, we know that this is 5x by y. Okay, so the area would be 5x by y, but you're subtracting the small square, which is x by x minus x squared. Now we're not done yet. We know that y is given by 50 minus 6x. That's minus x squared. So let's solve this. So we've got 5 times 50, that's 250. 250x minus 30x squared minus x squared. Okay, so therefore the area, would be 250x minus 31x squared. Now, if you didn't get that, that's fine. All right, you can still use, don't give up and go, I can't do this. Use this answer for the next part, because that's the reason why there's a show that question, so that if you don't know this, you can move on. Okay, so what values for x are possible in practice? Well, obviously you want